Let's say. Anybody knows where is Vanessa? Is she coming today? She's coming. Okay. Right, I saw the responses of your chapter 18 SLS. Okay, I think generally, okay, most of you can do it. Okay, maybe you'll struggle in terms of finding the distance and part, but let me address it when we go through the homework questions, because likely you will also face the problems in the homework questions. Okay, so we take a look at exercise 18.1 first. Okay, for exercise 18.1, any issues with question 7? Question 7, issues, okay. How about question 8? Question 8. How about question 12? Okay, maybe let's just go through exercise 18.1, question 7 first, alright? Okay, then later I'll move on to 18.2. Okay, shall we start? Now, question 7 says that a particle P travels in a straight line so that t seconds after passing through a fixed point O, its displacement from O is s meters, given that s is equals to this expression here. Okay, we want to find the expression in terms of t for the velocity and the expression and the acceleration. So we have already learned that in order for us to find the velocity, that will be to differentiate the displacement. So we will differentiate this expression over here with respect to t. Okay, either you write it this way or you can write it as ds over dt, that's fine. Okay, and then upon differentiation, we will get 12t squared minus away to be 4t plus. Okay, and then to get your acceleration, we will just differentiate our velocity. So dv over dt, that will give us 24t minus 24. Okay, so these are the two expressions for your velocity and also your acceleration. Okay, I noticed that in one of the questions that I gave for SLS, okay, some of you don't quite understand what the question wanted. Okay, maybe let me just go on to SLS, show you what I meant. Okay, so in SLS I saw that the response for this question here, right, in part I, okay, some of you gave me expressions in the answer. Okay, the question said over here, find the velocity and acceleration of the particle when t equals to 1. So they're actually looking for a specific value. Unlike in this exercise question 7, right, it is looking for an expression in terms of t. So do understand what the question actually wants before you answer the question, okay? Then moving on to part 2. It says that the values of, we want to find the values of t where p comes to instantaneous rest. Okay, so instantaneous rest would mean that your velocity is equals to 0. Okay, so when v is equals to 0, okay, we let it to be equals to 0 and then we have to actually go about solving it. So I can simplify it first so that I can factorize. Make sure that you have the correct factorization process. Okay, so it must actually match. Otherwise, you can use and solve by your formula. And then we get t equals to half. Otherwise, t equals to 4. Okay, so these are the two values of t such that it comes to an instantaneous rest. Okay, because rest will mean your velocity comes to 0. In part 3, we want to find the distance traveled by t in the first 5 seconds. Okay. Now, the challenge is that we need to observe in part 2, okay, when t equals to half and t equals to 4, okay, that is when it comes to instantaneous rest. When it comes to instantaneous rest, the particle will actually turn and go in opposite direction. So what this means is that if we have our particle starting at here, which is O, and that is when t equals to 0, okay, because the question says that it starts t seconds after passing through O, it goes in a straight line, and then at t equals to half, it turns going in opposite direction, and then when t equals to 4, let me just, okay, t equals to 0. When t equals to 4, maybe around here, it turns again. And then we want to find at t equals to 5. Okay? So this is just a rough idea of how the path is actually looking like. You really need to draw out this diagram in order to figure out the correct distance. Because I noticed that in the SLS lesson, okay, some of you still don't quite get how you actually find out what is the distance itself. Okay? Now that we have drawn it out, in order to find the distance traveled, distance will mean the exact path that it has taken up. So from t equals to 0 to t equals to half, t equals to half to t equals to 4, and then t equals to 5. You can ignore the curvature. Okay, the curvature is just an idea in itself only. Okay, we are just looking at straight line distance. So in order to solve for that, we find out the displacement when t equals to half from 0 to half. Okay, and that will be equals to s equals to 4 half cubed minus 27 half squared plus 24 half. That is equals to 5.75. So the formula will only give us the displacement, okay, because s is displacement. Displacement is the straight line distance from 0 to whatever time itself. So we know that this distance here is equals to 5.75. Okay? Then we look for t equals to 4. So when we're trying to find out when t equals to 4, the displacement will be from t equals to 0 to 4 itself, which is this distance only. Okay, it is not the path from 0 all the way to 4. It is a straight line distance. So s will be equals to 4 times 4 cubed minus 27, 4 squared plus 24, 4. And that would give us negative 18. Okay, so it does make sense to our diagram because with a negative displacement, it means that it is on the other side. Okay, when it is on the right, we usually take the right side as positive and the left side as negative. Okay, so this displacement is 80 meters. So you can ignore the minus sign. The minus sign only tells us the direction. Okay. And then finally, the other timeline that we have to look at is t equals to 5. So doing the same thing, we will get s equals to negative 55. Okay, so which means that t equals to 5 is when the particle is on the left of O. So this displacement is equals to 55 meters. Okay, so now that we have already laid all these things down, okay, to find out what is the distance traveled, we know that we need this 5.75. From t equals to half to this is another 5.75. From here to here is 80 meters. And then from here to t equals to 5 is equals to 80 minus away 55. So this distance is 80 minus 55 and that will be 25. So therefore, the distance traveled will be equals to 5.75 plus 5.75, okay, then followed by another 80, followed by 80 minus away 55. And that would be 116.5 meters. Okay? Questions? Yeah? speed. Average speed, because you're talking about speed, you take the reference from distance and also time. So it will be total distance over total time. So the total distance has already been calculated. That will be 116.5 over the total time of 5 seconds. That is 23.3 meter per second. Okay. For average velocity, okay, velocity is a vector quantity, so it will have to be total displacement, the corresponding vector quantity over total time. So the total displacement, okay, for the first 5 seconds will just be when t equals to 5, which is negative 55, over 5, so negative 11 meter per second. Okay, finding average velocity isn't quite meaningful, to be honest, because the value itself really doesn't express much things, doesn't express much information. Okay, so I don't really know why the question asks to find average velocity. So, okay, because that number is not meaningful. Okay, questions? Just want to check for question 8, part 3, not an issue. Explain why the particle will never return to its starting point. You all can explain. No, right? Sorry, let me just refresh my memory about this question. Okay, so in part, let's look at question 8, yeah? Question 8 gave us this to express the displacement. In part I, we wanted to find the velocity and the acceleration, which we have found already. In part 2, we want to find the distance traveled by the particle in the first 5 seconds. Okay, whenever you're asked to find the distance traveled, okay, you must always check whether there are any turning points or not, any turns. You cannot take for granted that you take the time and then substitute inside here to find the distance. Okay, so I hope that in part 2, you managed to find that there are 2 turning points. Okay, when t is equals to 0, that is t equals to 3 and t equals to 5. Do you need me to go through part 2? Okay, then I'll go through part 2. Okay, so in part 2, or rather in part I, we have already found. Just rewind a bit. Okay, so in part I, we would have already gone shorten the velocity expression as well as the acceleration expression. Okay, that is because you can differentiate your displacement once to get velocity and the second time to get the acceleration. Question 1 is the initial velocity and the initial acceleration. So that means that your t must be equals to 0 to find the exact value. Okay. Then in part 2, to find the distance traveled, okay, by the particle in the first 5 seconds, we must go and figure out whether there are any turning points. You cannot take for granted that t equals to 5, substitute inside here, and then you get the distance. No. This is strictly for displacement only. Okay. So what you need to do, okay, is that you need to find out the turning points, and that is to say to find out the time when v is equals to 0. Okay, so that is when your instantaneous rest, because when coming to instantaneous rest, there will be a turning point. So when v equals to 0, we solve the equation of 3t squared minus 24t plus 45 equals to 0. And then this one can simplify. Okay, such that we get this, and t equals to 5 or t equals to 3. Okay, so there are actually 2 turning points which explains my diagram over here. Okay, so we are taking from t equals to 0, the fixed point O. It moves in a straight line direction, and then at t equals to 3 it turns to be at t equals to 5, and then at t equals to 5 it actually turns again. But that doesn't quite matter because the question only wants us to find out the distance up to t equals to 5. Meaning to say we need to know what is this distance plus this distance. Okay, so we can find out when t equals to 3, our displacement will be equals to 57. Okay, so this is 57 meters. And then when t is equals to 5, that will give us 53. Okay, so this displacement of 53 refers to this displacement here. So to find out what is this, it will have to be 57 minus away 53. Okay, and that will give us 4 meters. Okay, so my diagram not quite drawn to scale. So therefore, the distance traveled will be 57 meters plus 57 minus 53. That will give us 61 meters. Okay. Yes.
But when the equation equals to 0, won't like it's like 3 meters?
When the equation equals to 0, a particle moves in a straight line, so that its displacement from a fixed point O is given by this when t is 5 seconds after motion has started.
Like if we equate s equals to 0.
Yeah, I understand what you're trying to say. Hang on. A particle moves in a straight line, so that its displacement as meters from a fixed point O is given by this equation when t is a time seconds after motion.
I think I almost asked you.
So the answer is not 61 meters, huh? It's 58 meters. Okay. Sorry, thank you for pointing that out. I didn't notice that. Okay, how do I try myself? Okay, sorry, let me go back. Okay, what Regine has pointed out, okay, is that it says that a particle moves in a straight line, so there is displacement from a fixed point O. So the displacement is being measured from a certain fixed point, that is O, and this displacement is given by S equals to T cubed minus 12T squared plus 45T plus 3. Okay, where T is the time in seconds after motion has started. So we notice that when T is equals to 0, when I substitute 0 inside here, I will find that my S is equals to 3. That means that, okay, the fixed point O is here, but when T is equals to 0, there is already a lapse of 3 meters. That's what the question is saying. You understand what I'm trying to say? Yeah? So there is a lapse of 3 meters. So continuing in the journey that what I'm just trying to describe over here, okay, how the diagram should actually look like is that when T equals to 0, it will move in a straight line, and then when T is equals to 3, it will turn. Okay, then after that when T is equals to 5, it will turn again. Okay, so what is the distance that we're trying to find? It will be the distance after starting time itself. So we're trying to find out what is the distance from T equals to 0, this path here, all the way to T equals to 5. Okay, then in the values that we have found, 57 meters as well as 53 meters, how does it look like in the diagram? It is always taken from reference with the O, the fixed point, because that is where this displacement is being measured. Okay, so 57 meters is actually from O itself all the way to T equals to 3. And then the other displacement of 53 meters is from O all the way to T equals to 5. Okay? So since you're trying to find out what is this path, this distance over here, okay, we will need to take 57 meters minus away 3 meters, okay, then followed by adding, find out what's this, okay, 57 meters minus away 53. So the correct distance traveled should be 57 minus away 3 meters plus 57 minus away 53. Okay, and that will give us 58. Okay, sorry about that, didn't notice it here already, but thanks for pointing it out. Okay, questions? Okay, I hope you know that when it comes to finding distance, right, it is really impossible to do it without a diagram. Okay, you really need to draw out a diagram in order to figure out what is the distance to find out. Okay, then going into part 3, explain why the particle will never return to its starting point. Okay, there are 2 ways that you can go about solving this question. One, you can actually address that when T is equals to 5, okay, it is where a turning will happen, okay, and the particle will actually go in opposite direction and will never return to T equals to 0. So you can give a qualitative explanation. Okay, so this is one way that you can explain it by stating that the particle travels away from the starting point and will not turn back towards the starting point anymore. Okay. Alternatively, like what we mentioned earlier, when t is equals to 0, s is equals to 3, so the starting point is actually 3 meters away from O. So in order to return to the starting point, okay, we are looking for the displacement to be equals to 3 meters. Okay, so if you want to solve it in a quantitative manner, okay, you can find that when s equals to 3, substitute it inside the expression for the displacement, okay, and then you try to solve. This is a solvable equation in the sense that it is cubic, we can still manage it. Okay? Then we can factorize out the t since all the terms have a t, and then we're looking at t equals to 0, otherwise t squared minus 12t plus 45 equals to 0. Okay? Then we're looking at solving a quadratic equation, but if you notice in this quadratic equation, by looking at the discriminant, it is less than 0. So therefore, this quadratic equation cannot be solved. There is no solution. Okay. So because the discriminant is less than 0, we say that this has no solutions. In solving this equation itself, the only solution is t equals to 0, which means that it is at the starting point. Okay, there's no other time values that will allow us to go back to the starting point. Okay, so therefore, so I'm showing you two different ways of solving this. It is not all the time that you can actually do it in a quantitative manner, whereby you try to seek out a value. Okay, because sometimes it could be exponential equations, it could be logarithmic equation that you do not have the skills, or you may not have the skills to actually go about solving. Okay, so it's just that this so happens is something algebraic and we can solve up to cubic equations. Okay, so actually we can arrive at such an answer. Otherwise, most of the time, we will have to observe the expression that is given, okay, and observe the situation that we have and come up with a qualitative answer. move off as well. Okay, just want to cover certain points. In part 3, okay, the distance traveled in the 4th second. I hope that you're looking for only at the 4th second. That means the displacement between t equals to 3 and t equals to 4, that should be 6 meters. Okay, do you need me to go through part 3? No need. How about part 4? Okay. For part 4 itself, right, it is actually the similar concept to what I just went through in question 8, okay, whereby you need to take notice that when t equals to 0, your displacement is negative 2, okay, which means that your diagram should actually look, I erased already, okay, the diagram should look something like this. So when t is equals to 0, we find that the displacement is negative 2, okay, which means that your O is actually on this side. Okay, hang on. Negative 2. When t equals to 0, displacement is negative 2. So from your O itself, okay, t equals to 0 must be on the left of your O, so that this is a negative 2 meters. So we're going in this direction, okay, followed by a turn at t equals to 3, okay, and then we want to find out what is the distance traveled in the first 5 seconds. So it goes on up to here, t equals to 5. Okay, there's no other turning point because that's what you have to notice in part 2, whereby the particle only comes to instantaneous rest at t equals to 3. It doesn't come to that. The other option of t equals negative 1 is not valid. Okay, so this is t equals to 3. Okay, so in part 3 you have already found when t equals to 3, s equals to negative 20 meters. In part 3, you would have found that when t equals to 3, s is negative 20. That means that this distance here to O is actually negative 20, or rather 20 meters. And then when t is equals to 4, s is equals to negative 14. So let's say t equals to 4 over here. We get this to be negative 14. Okay, and when t equals to 5, s is equals to 8. So from your reference point of O, t equals to 5, your distance is 8 meters. So your distance traveled will be 20 meters times 2 plus 8 minus away 2. We get 46 meters. Okay, why I take 20 times 2? Because I'm just taking this full length times 2. And remember to minus 2 at the end, and then we have this plus 8. Okay, and you'll get 46 meters. Okay, let's look at exercise 18.1, 18.2. Okay, for 18.2, any issues with question 5? Question 5, 18.2. How about question 7? Question 7. Is it? 7. 4. Oh, okay. Question 7, part 4. Okay. How about question 9? Okay. Then I'll go through question 7.
Doing a region. Why must you only say? Why must you
I
say?
did.
It's not like it doesn't exist.
I'll just very quickly display the answer for part I, 2 and 3.
I think it's correct. Not the explanation. I check the answers.
Okay, so just very quickly running through part I, just in case some of you are not that competent in solving your trigonometry equation yet. Okay, so in part I itself, the question wants when the value, you ask to find the value of t when the particle first comes to instantaneous rest. That means your b is equals to 0. So you let the expression given to you be equals to 0. And then in order for us to solve it, okay, we must have our trigonometry equation always to be in the basic form of tangent something equals to a number, or sine, or else a cosine. So individual trigonometry functions. And that can only be done by dividing across by cosine. Okay, and then we get 2 tangent t plus 3 equals to 0. And then we get tangent t equals to negative 3 over 2. Okay, this is a skill that you need to know, okay, when it comes to solving trigonometry equations. Then because your tangent is negative, that means that our quadrants that we're identifying is the S quadrant as well as the C quadrant, since tangent is negative. Then we find out the basic angle by taking tangent inverse of your positive 3 over 2. We will get 0.9279, making sure that our calculator is in your radian mode. Okay, whenever you're solving any trigo related stuff related to kinematics, we must be on radian mode. You cannot be in degree mode because it doesn't make sense for time to be in degrees. Okay, so you must use it in radian mode. Okay, then after that, your t will be equals to pi minus away your basic angle, because in the second quadrant, okay, to find out what is this angle, our basic angle is over here. So 180 degrees minus away basic angle. In other words, pi minus away basic angle. Likewise, for your fourth quadrant, we will take 360 degrees minus away the basic angle. Okay, in other words, your 2 pi minus basic angle, we will get 5.30. The question wants us to find out what is the value of t when the particle first comes to rest. So that will actually be 2.16 seconds. We do not take 5.30. Okay. Then for part 2, to find the acceleration, we will have to differentiate our velocity expression. Okay, so we just substitute your pi over 4 into it. Okay. In this question, they did not mention that your acceleration needs to be in exact form. Okay, so you can leave it in decimal. Otherwise, you notice that pi over 4 is actually your 45 degrees. It is your special angle. So if you want to leave it exact, that will be negative square root 2 over 2. Otherwise, negative 0.707 is also fine. Okay, since the question didn't specify. Okay. Then in part 3, an expression in terms of t for the displacement. So to find the displacement itself, we need to integrate your velocity. will leave us with 2 negative cosine t plus 3 sine t plus c. Okay. You cannot leave your answer as just negative cosine t plus 3 sine t plus c. Okay, you need to find out what is the value of c, and that will be equals to 4. Okay, so I leave it to you to actually find out the value of c. That can be done so whereby when t equals to 0, s has been given to be 2 itself. Because the question says that starting from a point 2 meters from a fixed point O, okay, the particle actually moves. So this is the information we will use in order to find the value of c. So c equals to 4. I leave the full set of working for you to do one. Then part 4. To find the distance traveled in the first 3 seconds, we know that at 2.16 there is a turn. So to draw out the diagram, our reference point O and our t equals to 0 is actually 2 meters apart. Okay, and 2 meters to the right because starting from a point 2 meters from the fixed point O. Then it will continue to travel at t equals to 0 all the way to t equals to 2.16. Okay, and then after that, it will continue to travel, and then at some 5.30, it will do a turn. But that is irrelevant because we're only trying to find out up to t equals to 3. Okay, so what we want to find is this distance here as well as this distance here. So what we will do, for accuracy, your t should be 2.1588 truncated 5 SF value. Find out what is the displacement. That will give us about 7.6055. Okay, by substituting into the displacement expression that we found in part 3. And then when t equals to 3 itself, finding the displacement, that will be 6.4033. Okay, so how do these numbers work in our diagram? So when t equals to 2.1588, your displacement is 7.6055, that is from O all the way to here. And when t equals to 3, displacement is 6.4033. So that is the displacement. Okay, so to find out what we want, we need to take 7.6055 minus away 2 in order to get this path. And then we take 7.6055 minus away 6.4033 to find the remaining path. And that will be 6.81 meters. Okay. For question 9, I know you said that there's no problems, but for part 3, maybe let me just explain. For the particle return to O, okay, how do we explain it? Because in this case, your velocity function is in exponential form. Okay. Okay, question 9, yeah? Okay, so in order to explain it, go through the whole question. Why after I asked, nobody said anything? Okay. The question says, a particle moves in a straight line from a point O so that t seconds after leaving O, its velocity is given by v equals to whatever. Okay, so we have a straight line leaving O itself when t equals to 0. Okay, your velocity is given to be this. Okay. Then in part I, we want to find out what is the initial acceleration. So we need to find out what is the acceleration expression, and that can be done by differentiating your velocity. If you want, otherwise you can expand your velocity first, then you do a differentiation. Okay, if you apply a product rule, essentially you're keeping the left side, differentiating the right side, and then we keep the right side differentiating left of 3, which is 0, so that's why there isn't the second part. So when t equals to 0, to find out what is the initial acceleration, that will be equals to be 1.2 meter per second squared. So that's the initial acceleration. Okay? In part 2, we want to calculate the displacement of the particle from O when t equals to 1. So we need to find out what is the displacement expression. That will be by integrating your velocity and we find that the displacement will be given by this expression, for which you need to find the value of c. The question mentioned that when time is equals to 0, it started at the point O, the reference point O, so your displacement s is equals to 0. So in other words, 7.5 plus c equals to 0, and c equals to negative 7.5. So s is equals to 7.5 e to the power 0.4 t plus 6t minus 7.5. To find the displacement when t equals to 1, just doing substitution, you will get 9.69 meters to 3 sf. at part 3? Part 3 says will the particle return to O? Okay, if you're trying to do it by a quantitative manner, it is not going to be feasible. Okay. Let me just erase this. So to return to O, right? That means that okay, so one idea that we can have is that when t equals to 0, we know that velocity is such that it travels in this direction. In order to return to O, that means that there must be a turn. Agree? There must be a turn in order to return to O. Okay, so we can check whether there's any turn or not. Okay, because if there is no turn, then there's no chance to return to O. Agree? Okay, so looking at this expression itself, in order to have a turn, this must be equals to 0. Okay? But then, to not even go and find that value of t, observing the expression itself, we know that an exponential function will always be more than 0 for all real values of t. In fact, even not talking about real values of t, since t cannot be negative, you want to say for all t more than 0 also can. Okay, so this is the first thing that you need to be aware about, that your exponential is always more than 0. Okay, so if you were to plus 2 on both sides of the inequality, we will know that your exponential plus 2, okay, is more than 2, which is more than 0. Even if you multiply by 3, it will still be more than 0. So therefore, your velocity is more than 0 for all values of t. So because it is really more than 0, it will never be equals to 0. Okay? And since it will never be equals to 0, that means that there will never be a turn. Since there will never be a turn, it means that it will never go back to the starting point. You understand the logic? One way that you can go about explaining it. Okay, just as I was running through it with you, I also thought that you could probably think about it as trying to equate your v equals to 0 find the exponential 0.4t equals to negative 2, which is not possible because we must be aware that exponential will always be more than 0. Okay? Then after that, end off, conclude, right? You need to say that hence the particle will not come to instantaneous rest. Make a turn towards O, the particle will not return to zero, to O. Okay, so this explanation remains the same at the end. So this is an alternative. Okay? If you are trying to think about it as particle returning to O, that means your S is equals to 0. Okay, we have found that S is equals to this, and if you try to actually solve when S equals to 0 and see whether there's any T value or not, it is impossible for you to go in any direction. Okay, because we do not have the skills to actually solve such an equation. Okay, so this will lead you nowhere. Alright, so if you try to do it by the displacement method, there is no nothing that you can come out of it. Okay, so that's why this is not going to be a valid answer. You need to tackle it through addressing the fact that there is no turning point. So with no turning point, it doesn't have a chance to return to the direction of where O lies. Okay, and hence it will never return to O. Okay, so you need to address it based on the velocity instead of looking at the displacement itself. Okay. Questions? If not, can you please pass the homework down to the front? In the meantime, I'm going to give you 2 worksheets. One a geometry related one, the other one is one that I will be running through today.
You want to sit with
Yes.